Okay, so everything I show you is posted at the GitHub repository. And yeah, here is README and so on. But let's start with a goal, what's going on and why we are doing it. So the idea is to use Unicity tokens to provide safe AI agent execution. And at best case, even it's possible to run agents if they are executed by independent, not related parties, which do not have to strictly trust each other. And the Unicity token would capture one execution flow from start to end. So there is an owner of a task. Owner specifies a goal and success criteria and some tools or permissions and limitations, what must be followed during the execution. And then every execution step adds a transaction to this Unicity token, which captures everything necessary to just see what went on towards executing towards the goal. And one question initially was that what would go into the transaction. So the first idea was to put entire LLM execution context into every transaction was added to a Unicity token. But it's like too much of information. And during this implementation, I just collected like all context generated by one agent running session into one transaction. One session means that one agent calls tools many times until he has figured out that he has reached his goal. And then execution can continue with another agent which has another goal. And in this example, it's like simple relationship. There are two agents. One is a worker doing a task, and the second one is an orchestrator which verifies if a goal is achieved. And the tools are LangChain, LangGraph, I think the most popular tools for agent running and agentic tool execution. And probably this kind of threat model makes most sense because there are like no really good ways how to verify inference if it's done securely using the right model, if the model was correctly trained and so on. There are attempts to do it using ZK or trusted execution environments, but very likely it doesn't make sense because the market have consolidated and we have like really large providers who are providing agent execution. Sorry, LLM inference for agents. But the agents themselves can be run by independent parties. It can be anybody. They can provide their own tools, and the parties are responsible for finding the right tools and making sure that the tool execution is safe, secure, and provides the right data. Okay, and to the demo. So it's in TypeScript. It seems that LangGraph has implementation in TypeScript as well. So main one is in Python. And to execute tasks, there are descriptions of the tasks. So we have like a couple of examples. One trivial thing, calculating Fibonacci numbers. And this one is more complicated one. I hijacked the crypto trading example. But yeah, let's look at the setup. Basically, we have a goal specified by the user, and there are success criteria and maximum steps, which is in fact a limitation. And then there are permissions, like the list of allowed tools which can be used. There are more tools available, in fact, and permissions, what can be done in a file system, because there are tools to read and write files, and network permissions, and then some resource limits, which we call guardrails, but there can be should be more and more sensible guardrails in fact. And when we have specified the task, we initialize a configuration. Configuration has two agents, which are using lightweight Google online models, and there is a Unicity configuration. We have trust base and aggregator configured. And this is where everything happens, which is one call implemented by the rest of this demonstration. It executes agents with a goal, with permissions, with guardrails, and with system configuration, and gets back a result. And finally, we store the end result. And let's run it. So we have a tool which mocks up the crypto wallet and the transactions. So we have a goal. We are minting the Genesis record. Genesis record captures the goal and permissions and guardrails and success criteria. Now we see that the agent have executed a bunch of tool calls. Get balance, swap USDT to alpha, swapping rest of USDT to alpha. We didn't provide actual numbers, but LLM is smart enough to figure it out. And then we said very vaguely that check online if a fair market rate was used. So it seems that the thing have decided to use Binance. Kind of surprising that it knows so well what are the API signatures, but as it knows it, why not? And then it calls calculator tool to compute the inverse of exchange rate, and then finally gets a balance and then writes a file with a result. Okay, I'll open it, the result at different place so that it's more readable. We have output and trading report. So this is the report. So we have initial wallet state, trade 1, trade 2, market rate check. It says that conclusion, market rate was significantly lower than one downloaded from internet, and there is a final result. So it figured out that it was cheated, but didn't complain. But the cool thing is that it used a calculator and used a web call to figure out what's the right market rate, to figure it out later, just based on this totally vague prompt here. Okay, and now the orchestrator takes over and verifies if everything is good. It's another agent, completely independent, that it should provide assessment for a user if the agent did run correctly, the executor agent. So it figured out that the goal achieved true, and confidence of everything being right is 95%. And there is some justification why he thinks so. Okay, he assessing if the agent is working correctly, not about if agent is cheating. And there are some concerns. While the identified and reported it, it indicates a potential issue with underlying training tool or market conditions. Blah, 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 but never mind, it's happy. So there is another Unicity transaction to seal it and run it. Everything is done. And let's have a look at the token. So this is a produced token. And this is basically why we are doing it. We are minting a new transaction, new token. And within this Genesis record here, we have a description of a dark, description of goal, success criteria, guardrails, somewhat arbitrary, but we show that we put everything into the Genesis record. There is an inclusion proof. There is a state, which we are ignoring because it's relevant for next transaction. And where we have transactions. First, we have initial state. There is basically nothing. It's initial state with empty context. And here we have execution transaction, where we have recorded all the tool calls of core agent is the executor. First, it checks balances, gets back the balances here. Sorry, it's not balances. It's already executing USDT to alpha transaction here. Success true and gets the balances back as well. Checks balances after it. Swaps rest to BTC. Then makes this API call. This is a result what Binance returned to us. Successfully parses it. Then makes a calculator call. Takes inverse of exchange rate. Blah, blah, blah. And now writes a report by using this write file tool. And everything is captured as a one transaction with inclusion proof here and so on. And the last transaction is this orchestrator agent's assessment. Reasoning, concerns, confidence that everything is done correctly. And inclusion proof. And this is it. Which concludes the demo.